Okay, cool. I'm talking about approaching parallel programming from the world of JavaScript. Who me? See if I can pause this. It's going fast already. So I'm Tyler. Some people might see me as Tees on several Slack channels. I hate PowerPoint, so that's why these notes are here. I like to do other things. Try and remind myself that I don't just program all the time. So I like riding bikes, writing haikus, climbing, computer music, making stuff. And I'm talking about something I made called Thread Count, which I made back in January. I like to build projects, but every now and then when I don't understand something, sometimes I try and just like do a deep dive of research into understanding a topic that I don't really get. So I did that, and I did that on the topic of parallel programming. So I'm talking about this because I came from the world of JavaScript first. I'm a self-taught developer, but lately I've been thinking of that more as like a community taught, because a lot of the people in Toronto have been very helpful in helping me learn a lot of the things that I know today. And making the transition into learning about topics involving parallel programming was kind of difficult. And I started to do it because I moved away from JavaScript after a time and started working with a language called Clojure, which is a really cool and nifty language that I like quite a bit. But as I moved into that sphere, I kind of saw a lot of words that involved parallel programming. So talking about threads, concurrency, locks, futures, these like buzzwords that I didn't really understand. And so I decided that I would just take a couple days and just do a lot of reading and try and summarize some of those notes. And you can read the whole doc online. I'll have a link at the end if you're interested. So for those of you who have more formal degrees in education and programming, this might be pretty boring. Or not news to you, but hopefully any who are in like a similar boat, it will be kind of helpful. So does that make sense? Can you guys hear me okay? Okay, great, awesome. Okay, so I actually need to be on this slide. So when you're talking about the JavaScript world, you're talking about an event-based language. A lot of people will say JavaScript is single-threaded, which a lot of people will also debate. So I'm not going to do that. But why does this matter? Like, when we're talking about parallel programs, we're kind of talking about a lot of different things. And you might hear people talk about what's the difference between parallel and concurrent programming. And that's a really huge topic that I can barely even scratch the surface of right now. In my mind, at least from what I've come to understand, I'm thinking of parallel programming as dealing with the ability to write programs that can leverage the fact that a computer has multiple cores. So you're able to write programs that can run faster because your computer has several brains, 2, 4, 6 brains, whatever. And I kind of mentioned Moore's Law right here because it was this idea that was kind of circulating that our computers were going to just keep getting faster at the same rate every 18 months or something like that. And that's kind of been disproven. We can only make the transistors or whatever inside our computer brains so small. And so the idea that we might need to start to leverage parallel programming has become kind of more prominent, especially as we continue to develop more complex programs. Like it's not getting easier, we're continuing to build tougher, more complicated stuff. So I want to talk a little bit about threads. Coming from the world of JavaScript, and maybe seeing a little bit of threads around, in a Rails program or just, which it probably shouldn't be in there. I was very kind of intrigued and confused by this concept of a thread. And as I did some of my research, I was like, what is this? Like, is this a physical thing that's living in my computer? Like, how can there be several things that belong to one program? What I kind of distilled out of that is that you have processes running on your computer. If you open up your activity monitor or if you run top in your terminal, you'll see a lot of programs running. Those are processes. And they all have an ID, and they all have the ability to have at least one process, or one thread, sorry, or more. And once you start thinking about this stuff, you're thinking on an operating level, like operating system level. And when you start programming with threads, you start to deal with kind of complicated issues like race conditions. One thing that I found really interesting in my research was that there's this idea of a Pthread, which is in the C library. And I still don't really understand this, but as far as I can tell, having standards across computer architectures is really complicated. C uses something called a POSIX thread, and that's a standard that kind of applies across C, I guess. So that was interesting. So moving on, I kind of wanted to talk a little about this idea about green threads. Last Polyhack, Rohan did a talk on Elixir. And how many of you folks have heard of green threads before when programming? Okay, I see a couple hands. Elixir is really hot right now. It seems really cool. You can do a lot of interesting stuff. One thing that I've seen people say is that you can spawn millions and thousands of threads. They're green threads. And I'm like, well, what does that mean? Are there millions of threads running through like my processor, like at the core level of the kernel? And so I kind of wanted to debunk that for myself a little bit. And this idea of a green thread kind of came from Sun Microsystems and Java way back when. And it's kind of persisted to this day and is becoming a lot more popular and used widely in languages like Go and Elixir. So a green thread, and I might butcher this a little bit, but it's because I'm still kind of grappling with what it is, but you're dealing with quote-unquote threads different than the kernel level threads in a virtual machine. So you have Java existing in the Java virtual machine. You have Elixir or Erlang living in the Beam virtual machine, and you kind of have this interesting relationship going on between a user space, which is your virtual machine, and the kernel space. And there's this really interesting relationship between how these thousands of threads you can spawn can be parked or moved and exist in a relationship with your kernel threads. So I definitely would recommend reading up a little bit about that if you find it interesting. So I was kind of saying, if you can run the JVM, then you get threads, and you get threads, and you get threads. Because it's kind of like, if you can run the JVM, then you can have these threads. Even if your computer can't run parallel programs, or even many threads at all, you can still kind of have this abstraction layer, I guess. So yeah, I'm still kind of coming to grips with that concept, but I find it really intriguing. And I just kind of want to finish up by talking about this kind of underdeveloped slide. So when you start dealing with really concurrent and parallel programs, you're dealing with a lot of challenges. It can be difficult to write these kinds of programs for several reasons, among which you have shared mutable state. I write in a language that kind of privileges a mutable state, which is Clojure, which kind of lends itself to easing some of those problems. But what I've kind of learned is that there are these really cool concurrency models that take the concept of sometimes green threads or kernel threads and give you abstractions over them. So I won't talk about these today because this one is like a giant philosophy, apparently. And this one is was talked about last month. So that's my way out. But so CSP is something called communicative sequential processing, I believe. Clojure and Go both use it. Go was kind of like a really popular one. Or it's the most recent big popular one, I guess, that uses it, but kind of came around in the 80s, I think. And the actor model is pretty popular in Elixir and Erlang, but I believe other languages can also use it. So I guess I would just finish up by by saying that as a front-end dev who kind of came into learning programming from a very autodidactic place and kind of like a self, chugging along way. I would say don't be discouraged by some of these concepts that might feel like you need a degree to kind of tackle. I found that it's been really informative for coming to approach even the front-end stuff that I do on a day-to-day basis. So yeah, that's my talk. Does anybody have any questions or thoughts? I'll try my best to answer them. I know we are also on a time schedule, so we could also jump to the next talk if you want. Great. Okay, I see one question. It's Ray, right? Yeah. Okay.
I'd like to ask, what's the breakthrough? Like, how do you go from, I don't actually understand this topic, to, hey, at this point, I understand now, I move along to the next topic. What was the breakthrough for you?
Yeah, I think it's still happening. Part of it is having a place like Polyhack to kind of force me to think about this stuff in a way that I can present it, which is awesome, and I'm glad you folks are doing this. Another part of it is writing it down and seeing like, okay, can I express this to somebody else? And I think I relish the idea that when you can give yourself the chance to teach or at least try and explain something to someone, in whether it's a mentor-mentee relationship or just with a pal, it's really affirming, I guess, to help you realize where you're at. For me, I think it was just getting to a point where I looked back and I was like, I remember when this concept was kind of strange and scary, and I just gave it so much power over me by saying like, this is complicated. But it doesn't have to be like that. So that's a great question. Thank you. Yes, Wait, Dylan? Oh, okay, great. I did it.
Yeah, how do you know when to stop? Because I know personally it's very easy to get lost going down the rabbit hole with anything.
That's a really good question.
So for this, for example, how did you know when to call it quits?
Well-
And just say, you know what, I'm just gonna chug along here. Next thing.
Yeah. I don't know about you folks, but finishing projects is hard. But that's a good question. I think I came to stop. I decided that I would cap it at trying to understand what a thread was. And that kind of led me to green threads. And then I wanted to stop at concurrency models because I was seeing people writing entire books on it. And I knew that I wasn't going to be able to understand, well, or necessarily just be productive in the rest of my life if I did that. So it was kind of like, I know that I need to stop somewhere. And when it gets to a point where I'm seeing a lot of academic research and I have other big bucket list of things to do, I guess that's kind of when I try and call it quits. I think for me also, I just want to try and build documents that are accessible. And so if I'm getting into a topic that's not super accessible, then I'll maybe save it for another section entirely. Cool. Yeah.
I know there's a trend to do everything in JavaScript right now.
Yeah.
Can you give some examples of when you would want to use threading in JavaScript versus just using a language that was built for threads?
Yeah. I actually don't even know how you can do threading in JavaScript. Like I know you can spawn new processes of Node, or you could. I know that web workers kind of give you the ability to have concurrency in the browser, but honestly, like if you, I used to work at this place that it was easier to send messages from Ruby to an Elixir process just to make use of its concurrency model. And if you have the luck to do a greenfield project, I guess it's just the matter of thinking carefully about when you might or might not need it. I think that using threads and parallel programming probably, like if you're building a CRUD app or a web app that is mostly about data logging, it might not be necessary. But I'm not sure if I know the answer to that. Does anybody have any thoughts on that? You know, if we're using JavaScript for everything and it kind of is like this single-threaded tool, sort of single-threaded, yeah. Oh, yeah.
I mean, computationally bound problems are problematic for JavaScript in particular, so that's a time you might want to go somewhere else. Was that the question even?
Yeah.
I think so. That was pretty cool. Yeah. For those of you who might be already really familiar with this topic, would anyone have any recommendations for what I should look into next?
That's a good question.
Yeah.
There's some really interesting stuff with Go about concurrency versus parallelism.
Yeah.
And for me, that kind of like that's where I learned a lot about what concurrency is and how like CSP actually influences those ideas in Go. So some of the and that's like kind of it's on the like official Go like blog.
Their docs as well.
Yeah, and they link it to a couple interesting papers. Like the CSP paper in particular is really good.
Okay. Wow.
Yeah, there's some good stuff. There's a guy that writes a blog called Morning Paper.
Yeah.
And he'll kind of like throw these different papers out, and there's some really interesting concurrency stuff on it.
You should send that to me in the Slack. If anybody's interested, I do have the doc available on GitHub. That's me, if you can read that. I definitely am happy to incorporate pull requests. I love open source. So I guess I should end off with that. Thanks, everybody.